Hey everyone, check out this vending machine. See how all the things got stuck at the bottom here? Whoops. Wasn't supposed to move it. Wouldn't that be a fun prize? I want you to think about if you got one chance to knock these snacks down by pushing one number. So it appears B0, B2, B4, B6, B8, and so on. Which of these numbers would you push and why to see if you could get the snacks to fall down? For me, the one I would pick, and not saying this is right, this is just my guess. My guess would be that I should hit B6. And I said I would hit B6 because I think it's the heaviest item above the ones that were stuck. So these other chips look pretty light. And I know from experience that they're lighter, I would imagine, than this beef jerky. So I would pick this one, hoping to knock this Dorito and Sprees down so that the rest of them would fall. Again, I don't know if this is right, but that would be my guess. And as we continue to look at vending machines, I want you to look at this one down at the bottom, and I want you to think about which number you would push, aka which one do you want? Double Mint, I don't know what this is, Kit Kat, Twix, peanut M&Ms, or regular M&Ms. So which number would you push to get those? So this is some data that I've collected. So you can see here that one person picked 55 to get the peanut M&Ms. 3 people picked Kit Kats. So they all picked 53 in order to get the Kit Kat. And then one person picked 51 to get the double mint gum. So we know that that's how a vending machine works. If you look here, and this is what you want, you have to push this number, 51, in order to get it. So you push this number, and the double mint gum comes out. Or it should, right? If it's functioning, if it's a working vending machine. If you push 51, the double mint gum should come out. But what happened here? I want you to figure out what's wrong with this list of the numbers that we push and the things that are coming out. What's wrong with it? I agree that this first one is correct. 55 would still get us our peanut M&Ms. No one else did 55. I see that this person hit 53 for Kit Kat, which again is what I see here. This person, though, picked 53, hoping to get and got out peanut M&Ms. Something's not right here. So this person pushed 53, but peanut M&Ms came out. Pushing 53, peanut M&Ms came out. That seems like this vending machine isn't working or isn't functioning properly. Because if you push 53, you should expect to get Kit Kats every single time. So that's what this person said. But this one, this fourth person here, this one is not right. So it's not functioning because you pushed a number and you got something else out. It's something different than you should have gotten. 53 should get Kit Kat every single time. So this one is not functioning. To go back, this one was functioning because every time you pushed a number, you got out what you expected. Every time. 53 was always Kit Kat. 53 was always Kit Kat. 53 was always Kit Kat. So this one was functioning. This one was not functioning. Moving on to drinks. So which number would you push here to get which soda? Personally, I would probably hit B5 in order to get Sprite. I like Sprite more than Coke or Diet Coke, so that's the one I would pick. Again, these are some results that people had. So some people chose A3 to get a Coke. Is that what we expect? A3 to get a Coke? Yes. I'll change that color just to be able to see it more. So A3, we should get a Coke. But now I see down here that this person pushed A4 and still got a Coke. So they pushed different numbers, but the same thing came out. Is that also supposed to work? Is that how this one works? If I push A4, am I still going to get a Coke? Oh, yeah. I think that's still functioning. What about this last one here? This one says A5, still Coke. Looking at the vending machine, A5, still Coke. So what we're seeing here is this vending machine isn't functioning properly. I would say so. I would say that it's functioning. Because if you push A3, you should get a Coke. A4, still a Coke. A5, still a Coke. So it seems like this is also functioning, even though you can push different numbers. These different numbers all got you the same result. Interesting. But it's still functioning. So how can we say that it's still functioning? Why does this still work? Oh, because that's how it's set up. So all of these options, even A2, they all have the same thing to come out, or the same output, even though you're putting in different numbers, the same thing is coming out with each one. So let's try and summarize that between functioning and not functioning. So in our first example, we had a functioning one because as we pushed the same numbers, the same things came out. 53 Kit Kat, 53 Kit Kat. So every time we push 53, the same thing should come out, a Kit Kat. For the second one, we had that it wasn't functioning because if you push the same number, 53 and 53, different things came out. So this one was not functioning. Our third one, even though we pushed different numbers and the same thing came out, we could still say that it's functioning because that's how the machine was set up to work. So this is how I simplified this in order to remember. If we put the same thing in, the 53 and 53, we should get the same thing out, Kit Kat and Kit Kat. If I put different things in, sometimes the same thing comes out, Coke and Coke. It's not always going to be that way, but sometimes that can happen. So these, when this happens, we said it's functioning. We can also cut off the ing and just call it a function. So this would be a function. We know that a function, for every input, there is exactly one output. So 53, every time Kit Kat comes out. So one output for every input. That doesn't mean, however, that if you put different inputs, that the same thing can't come out. Sometimes that happens. But looking at this blue one over here, what we consider not a function is if you put the same input of 53 and you get different things coming out. This one input has two different outputs. Since they're not the same, then this is not a function. So let's look at what that looks like in a table if we take out the vending machine part of it. Still thinking about the vending machine as we go, but it's asking us which one is a function and which one is not a function. So now I know that a function, one input, has one output. So my input here is -1. I see the output is 5. There's no other -1s here, so I can say that this one is okay. I see 0, no other zeros, so then this one is okay. Same thing here. 1, 2, 3. There's nothing that repeats in this input column, which means I don't know if any input has more than one output because all the inputs only happened once. So that means this one is a function. What would happen if I added a line and I said 1 and 4? So 1 was the input and 4 was the output. Oh, well now I do have one that repeats. 1 has an output of 4. Down here, 1 has an output of 4. Is that the same or different? Oh, it's the same which means it's still a function. So looking at the second one, I see 3, there's nothing that repeats. In the input, there's no other 3's. Oh, the ones that I see that repeat are 4 and 4 for the inputs. Let's check the outputs. The outputs are different. Oh. If I put 4, say A4, into the vending machine, and I get out peanut M&Ms the first time, and I push A4 again, and I get Kit Kat out, is that functioning or not functioning? Or not functioning? I would say not functioning, or what we call not a function. So now that we've gone through this, I want you to pause the video and label each of these as function or not a function and see if you can explain why. So now that you've tried these, here are our answers. The first one is not a function, and I'll show you why. The 2's repeat as inputs, and if you check the outputs are different. So this one, not a function. Moving down here to number 2, again, all of these inputs are repeating, so then we have to check all of them to see if the outputs are all the same. All of these outputs are different. I could have just checked these 2 and seen that one output was 2 and one output was 3 and said, nope, not a function. Number 3 up here at the top, the -3 is the input that's repeating. And again, they have different outputs, 0 and 2. The last one, however, doesn't have any x values that are repeating. So then I could say that this was a function because each input has one output. Again, if I added a line and I had 2 here and 4 there, 2 as my input, oh, they're both repeating, which is fine. We just have to check the output. 2 to 4, 2 to 4. Oh, again, one input has one output, so we can say, yes, this is still a function. Now that we've seen this in a table, we're going to move from tables to equations to see if we can tell if they're functions or not functions. To do that, this is our equation right here, y equals 5x minus 3. Oh, this looks familiar. It looks like y equals mx plus b. Okay. But what I have to do here is these are my inputs, and I know that my inputs are always my x values. Here my output, that's my y value, that's what's coming out of the machine. So here what I need to do is take the 4, the input of 4, put it into the machine, into their x value, and solve for it to see what comes out for our y. So I know that 5 times 4 is 20, 20 minus 3 is 17. Again, same idea for the second one. It's still 5x minus 3 is our equation right here. So what I'm doing is I'm just taking out the x value and putting in our input value for it. So 5 times 10 is 50 minus 3. The output here would be 47. For the last one, oh, I see 4 again. If this is a function, I know that I should get 17 out because I already had 4 as an input. So if I put 4 in again, I should get the same thing out if this is a function. Again, 5 times 4 is 20 minus 3 is 17. So the input of 4 has the same output each time. And this is why, because you're putting it into the same equation. So this is a function. Go ahead and you try this one, putting in all of these inputs and see what numbers you get out. Go ahead and pause the video. So here should be your answers. These outputs should be 12, -2, 8, and 12. So again, we can see that the input of 3 has the same output of 12 every time because you're putting it into the same equation, which means your answer should be the same. Which means this is also a function. Each input has one output. So we started with vending machines, seeing what went into the vending machine, what numbers we pushed, and what came out. So I want you to remember that functions are like vending machines. That's how I remember what goes in. The same thing should come out every time. Every time I push A4, I should get a Coke. Every time. Function means that each input has one output. If we put the same thing in every time, the output won't change. It'll stay the same. Again, B5, always get a Sprite if this is a functioning machine. Lastly, when we know the input, we can use our equation to solve for the output. That's what we just worked on. And this is under 8.F.A.1, talking about 8th grade functions, if you want to look up more about that. Lastly, here's our 2 con assignments for this week. For this lesson, recognizing functions from a table like we did at the beginning, and then evaluating functions, putting the input in and seeing what the output is. Go ahead and log into Khan, work on those 2 assignments, and show us what you know.